Apologize for my voice. It was a very late night. And I think I'm mostly here. But I think I kind of like, a lot of this is going to depend on what you guys want from this, because I can go in as deep as people want, or as kind of high level as people want. And I see a lot of familiar faces. So it's kind of, I think it's going to be kind of a mix. So I assume, should I just like assume everyone here knows how nodes work, pooling, I mean the basics? So basically go right into the contracts? Show of hands? Is anyone like, okay, just like high level basics?
Bunch, I think.
Okay. Yeah, so I think it's really, I want this to be whatever you guys want, to be honest. It's a little bigger than I planned for in some ways. So it's not quite as intimate of a training session as maybe I thought it was going to be. But let me just go through, I guess, kind of the high levels. The one issue with, as a part of designing this with a pooling protocol, is when a given Algorand account has to be on, obviously it has to go online, and it can be any account. So it's your own account that goes online. You have to submit you have to create participation keys, which are temporary. And usually, sometimes in the past, people would create them for like a year. But, and it's because you want to kind of set it, create it and forget it, right? But realistically, you don't want them to last that long. The keys themselves, if they're exposed, is problematic. The keys should never leave the node, the participation keys. So the participation keys are created, and then the account that it's kind of linked to has to go online. So that's the only time that account actually issues a transaction, is against those keys. So normally, if you have your own algo and run your own node, there's no, your algo is completely liquid by default. Like you can spend it at will. But however, you have to kind of go online against that key whenever it expires. So there is some upkeep involved with it. Well, when you have a contract approach, then it's the same thing. The contract is no different than either account. So all the account needs to do is be able to issue a go online transaction, to be able to go online against the participation key. So the basics is you need to be able to have an account that can go online, and then it can participate in consensus. But you need to be able to you want that account to be managed in such a way that it will automatically renew, automatically go online, and have constraints. So it's like those are the starting points in a sense. So then you have, I want this protocol that I can have basically an unlimited number of validators who then have a set number of pools. But it's like, okay, what constraints do I then need to have? The pool needs to have a minimum of, today, 30,000 algo to be eligible for incentive rewards. And then there's a maximum of 70 million. And that could change. But then there's also maximums that you have to consider that with Algorand, approximately 22% is enough, 22% of online stake is enough to halt the chain. So you have to be really careful and concerned that no one account or even one validator or one like owner in a sense of pools has enough stake to be a problem for the network. So it's like I also wanted to make sure that there was constraints in the protocol around that. So I wanted to make sure that the protocol allowed arbitrary validators to have a finite set of pools, because you can only have a certain number of keys per account. Keys per node. Because when you have multiple participation keys on a node, you can have quite a few, but it's in the code. It's not. There's kind of mutexes around access to those keys. So as a part of voting for those keys, it's not fast path in a sense. So once you have like 3 or say 4 keys on a single node, then if they have enough stake where they're voting and proposing like every block, it'll be an issue. And so like you can't have like 10 keys on a node. Like you can, it's just there's a good chance you'll probably miss. Your performance won't be there. So I also wanted to make sure that the protocol had constraints on the maximum number of pools per node. But then node is kind of like a figurative thing because there's nothing, it can't know. Like you could have virtual nodes in this protocol and have all of them, you could basically have multiple virtual nodes on the same physical machine, but it wouldn't know the difference. But the reality is the performance would probably suffer. And so users would see that as being a lower APR, right? And then so I want to have the data there to be able to detect that as well. So there's also a limit, and because I intentionally also wanted, because when you give a liquid staking sort of protocol, then if I put algo in, you're going to get back some token. So that token represents the ledger in a sense of how you can track their stake. Well, if you don't have a token, then I instead have a ledger. And then that ledger, I'm basically limited in terms of how much storage I allocate for that ledger. And this is also very intentional as well. So I allow a maximum of 200 stakers per pool. And then you can have up to 3 pools per node and up to 8 nodes. So you can have a maximum of 24 pools per validator, but then the validator's stake is limited across all pools based on live state of the chain. So so basically, the validator when you create the pool, when you say add validator, the choices are you basically define an owner account, manager account, and commission account. Normally, owner would be a cold wallet. So you'd specify a cold wallet for the owner account, and the owner is the only one who can change certain things. Many of the parameters are unchangeable because like you can't change, you define a commission, you cannot change the commission after the fact. So you don't want to have like just people staking to you, you say, oh, I only take 0.5%, and then a week later, I take 60%, right? So the commission is fixed, and then you can also define gating parameters. So you can say, in order to join this pool, you have to own you can say any asset by this account. If you own any of the asset created by this account, you can join my pool. So that would be like an NFT creator, for example. You can say, do you have to have this asset ID? So that'd be a token, for example. And you can say you have to have at least this much of this token, right? You can say an asset created by an NFT, and then that's any account linked in the NFT, any asset created by any of those accounts. So that could be like an NFT project that has 7 creator accounts, and then it would be any of their NFTs, right? You can say an NFT segment, so then if they own a segment of my root, think of like a project, because they get revenue from people buying those segments. So they could say, if you hold one of my segments, you can join my pool. So it's quite flexible in the gating. And then that gating basically is only on entry. So in order to add stake, every time you add stake, that's when the contracts match. There's nothing involved in terms of like each epoch update, whether or not people get kicked out, but the provisions are there to kick people out. So there's so basically the owner or manager can refund stakers. And in the default case, most cases, that's going to be for if you need to sunset your pool, if you need to basically like, oh, hey, I'm shutting this node down, or I need to change parameters, you could basically kick people out. They get all their rewards, their tokens, whatever, back, and then you can sunset the validator and basically make it so no one else can add stake. But as a part of that, then the mechanism is there, provisions are there, where you could have a watcher and see if you wanted to kick people out actively, if they no longer met the criteria, then you still could. You basically say, do they match the criteria, and refund them. And then you can also define a reward token. So you can say for every epoch, which you define, and the epoch is defined in blocks. So it'll be like a calculation. I can say here, like every 24 hours, and it'll say like, well, based on the current average block time, that'll be X number of blocks. So the epochs are always in blocks, and then it'll show users an approximation of how long that's going to be. But the key is in the epoch is that is when the commission is taken. So if I say I have a daily epoch and I set 5% as my commission as a validator, then that means once a day, whatever rewards were accrued in each pool, per pool, I'll take 5%. And then the rest is kind of handed out in a sense or accumulated to all the stakers. So all the stakers' rewards compound. So each staker is not like airdropped, the rewards, they just accrue. It's compounded inside the pool. But stakers can remove at will. But you can also define a minimum entry. Because there's a limited number of stakers per pool, you need to have like, say, well, if you, since it only allows 200 stakers per pool, you wouldn't want to say one algo as the minimum, right? Because you need at least 30,000 for the pool. So you might say 1,000 or something like that, but that's still a far cry from 30,000. So the ability for people to participate is still going to be quite high. But it also is there to prevent people from kind of spamming your pool. I mean, you could have, at a certain point, there's no reason you couldn't have competitors who, like, if you only allowed one algo, they could just spam, create dummy accounts and fill your pool with 199 stakers, each with one algo, right? And then now you've got, 1,000 algo, and your pool's basically dead, right? So you want to set the minimum entry stake reasonably, but not too high. But then between the minimum entry stake and being able to have multiple pools and gating, there's a lot of flexibility. But kind of circling back around as far as the constraints of having the limited stakers, all those things, all that was kind of very intentional because I kind of want to force more nodes, more pools, and more diversity. It's like in some cases you might have people just one pool, one node, they're a validator, that's it. But I want there to at least be a forcing measure that if they really are going to have a lot of stake, they're going to be forced to have multiple nodes. And so I kind of wanted that as much as possible to somewhat force that in the protocol.
Patrick, have you considered applying the gating criteria to the payouts of accumulated rewards so that someone who may have gotten in with a token in their account has to continue holding that token to receive future payouts?
So I don't know if it's going to come through, but the question was whether or not you could have the payouts factor in whether or not you still meet the gating criteria. And because you can refund as a part of the contract, basically it's just a matter of, it's open source, the node daemon. Because there's basically there's a lot to cover here really, but as a part of all of this, there's pools that are created, and then there's a node daemon that you run alongside your nodes that has to create the participation keys and automatically go online. So that node daemon, as a part of its monitoring, could very, very easily reassert and check the gating criteria for each staker. It's just that depending on the gating criteria, it's actually easy for the contracts to verify this gating criteria, but it's a lot of work for the caller. Because you basically have to, as the caller, you have to, for some of these things, assets created by NFD or whatever, right? It has to iterate each account, find every asset that it's ever created, then iterate the staker's account, and find any matches. And then if it finds a match, it goes, okay, it has to offer hey, when I add stake, this is my kind of offering, and does this meet the criteria? So it's easy for the contracts to verify, but it's more work for the caller. So if you had 200 stakers, it's doing 200 times one at least, if not potentially 6 accounts, whatever. So it's a little bit of work, but it's nothing crazy. But the node daemon could certainly do that, and then as a part of its kind of as a part of its kind of, it has like multiple processes, because it monitors all the keys. It checks, it creates 7-day keys. So like when you bring the node daemon online, it says all you do is you tell it your validator X, your node number Y, and here's the key to the manager account. And then it automatically talks and algo the nodes. So the configuration is all in the chain to a great extent. So it talks to the nodes and gets its data from the box storage. It goes, oh, okay, there's 3 pools on this node, and I need keys for those. Do I have keys for those? Automatically goes online against them. It checks to see when they're eligible for renewal, things like that. But that same daemon could easily check that and refund people, and to kind of kick them out if they no longer meet the criteria.
Oh, so it could selectively kick them out?
Oh yeah.
Oh, okay.
Because like there's a call to basically like refund the staker.
Oh, I didn't realize you could do it in one. I thought it was the whole.
Oh no, yeah, you can.
Okay.
Because it's so there's actually in the CLI you can basically you can.
So you would kick them out at the time you're preparing the payout.
Yeah, or anytime. So if I like here's I'm just running the this is just compiling the code real time and running the CLI. But so there I was querying a live. I'm just picking someone else's validator and displaying their ledger. So it's all the accounts that are in that particular pool for that validator, when the last epoch was, when the next payout is, how much reward is currently available to be handed out as a part of the epoch, and so on. So it's quite powerful. But the node daemon could do that, because you can, as a part of the pool commands, you have a pool payout. So I can force a refund in a sense, but in the contracts, all it's doing is iterating every staker and paying them out. There's the flexibility is there, but let me getting a little off track. There's just a lot to cover. Again, as far as creating the validator, the owner and manager account, the manager account has to be a hot wallet, because the manager account is the account that actually you'd create mnemonics for and to provide those mnemonics for the node daemon, because it has to use those keys to sign the go online transaction. And the manager account, the contracts know who owns each validator, who the owner or manager is, and only the owner or manager can call those contracts for that validator. So when you say I'm validator 1, that's validated by the owner or manager account calling it. And so the manager account, those keys have to be on the nodes. And so because they're exposed, that's basically assumed hot wallet. That's why there's the 2 accounts. So that their manager account has limited abilities. The manager account can just go online, it can refund people, and I think add pools, that's about it. Whereas the owner account is who can change some of the criteria. So the owner account, you'd probably be using the UI and like a cold wallet. And then manager account is hot wallet, and the keys are on each node through like an END file, or there's a couple different options for that. The commission account is where the rewards actually get kind of airdropped per epoch. So as a part of each epoch, if you say it's daily, then or hourly, then that commission account is what gets paid out per epoch call. And the node daemon will call that every epoch. So if it's like hourly or whatever, it figures out like the start of each epoch, and exactly when it hits that start, it will call that for every pool. And so you would get paid out for every pool that you had that commission of what reward was available, and the rest would be distributed to the stakers. And any questions, just feel free to speak up. So that's the kind of the basics of how you define it. Like I said, you have minimum entry stake, the epoch length, the commission percent. So which can be pretty low, because that if you had a very short epoch, it's a combination of things. If you had a short epoch, then you're paying more fees because it's going to be about 20 transactions worth or so of opcodes for each epoch update. And so the manager account pays those. But then if you have a too fast of an epoch also, then your percentage is going to be much higher for the users, right? So if I say I take 5% and I have hourly epochs, well, that's 5% every hour, right? And so I think it's going to be interesting to see what people choose. I think, every hour might be a little too frequent. Particularly, then you'd have to factor in and lower your percentage, your commission, realistically. So I expect people to kind of play with it and figure it out, and then like, okay, that was wrong, and they sunset their validator. And when you sunset your validator, you can even say, hey, I'm moving to this other validator ID. So you can kind of even give hints to people to say, like, I moved here, right? And then once it's sunsetted, then people can no longer add stake, but they can unstake at will. So it's like they could have shut down their node, but it's like the algo is still there, right? And then you can unstake at will. Any other questions? Any questions on the validator configuration? We can get into back in the contracts. No. So the gating, the reward tokens. Actually, yeah. As far as reward tokens, you can pick any asset to give out as a reward in addition to the algo. So the algo that accrues is compounded for each staker, and that's just like tracks the balance. You can also say, hey, I'm going to give 10,000 of my token out to the stakers per epoch. And then that will be divided in the same way that the stake is, in the same way like their rewards are. So if I say give out 10,000 per epoch, and I have 2 stakers and they're each 50%, they'd each get 5,000 of the token. So if I had 4 stakers, they're exactly 25%, they'd get 2,500 of the token per epoch. And basically, as a part of setting up the pools, the pool number 1 is kind of like the magic pool for reward tokens, because there has to be something that holds those tokens and is allowed and able to send them out. So when you specify you have a reward token, it automatically opts in. Pool 1 says, hey, wait, my validator is defined a reward token. I need to opt in to its reward token as a part of its creation. So pool 1 automatically opts itself in to your reward token, and then you just need to fund it. And that's kind of independent, up to you. Like, it has no way of enforcing that. So if the reward tokens aren't there, people just won't get the payout. But it's like things won't break, they just won't get the tokens. So it's R and U, and people can like check to see like the token balance and the validator details. But it's up to you to make sure that's kept topped off, or just put tons in there. And then there's mechanisms to like send the tokens back to you. So as a part of you like sunsetting a pool, you can like get back the tokens you put into the pools if need be.
Do you have to sunset it to get the whatever extra?
No. Like it might need to like add something to the CLI to like do that. But in terms of the contracts, you can say, hey, give me back the tokens. And then the pool and the validator contracts have to keep track of what is spoken for, right? So when you can show here, so this is, I think this is everything. This is basically the state, global state and box storage for the contracts. So validator contract is global state in boxes, and so global state. So you can look at there's 2 contracts: the validator contract and the staking pool contract. The validator contract, there'll be 1 instance of it for the entire protocol. So like app ID 100 or whatever will be like, that's ready. That's mainnet, this application ID. That's all you need to know, and that defines everything. And then there's a staking pool contract that, as a part of the bootstrapping of the validator contract, the staking pool contract is loaded into box storage of the validator contract. So the validator contract itself acts as a factory for the staking pool contract instances. So that validator contract ID is everything. So it's both the state of the entire protocol and contains the bytecode of the pool contract as well. So, and then once it's deployed, it'll be completely immutable for all of it. But so for the validator contract, you'll have num_v, which is the number of validators, num stakers, and staked, which is just kind of like how many stakers are there, like the entire protocol, unique stakers, how many validators, which is just a sequential ID. So the very first validator is 1, 2, 3, and so on. And then total staked. And then from there on, it's boxes. So you have a V and then validator ID, which is just the 64-bit, 8-byte big Indian integer appended box. And then the validator ID, so that's for each validator ID, it's like here's a big struct that is all of its data. So the validator info struct, then you have a config, state, pools, token payout ratio, and node pool assignments. And as a part of that, you'll see there's the state, for example, has a validator current state structure. You have number of pools, total stakers, total algo staked, reward token held back, right? And so that's basically for this given validator ID, how many pools does it have, how many stakers for this validator, how many are staked, and then the reward token held back is because it doesn't airdrop to everyone during Epoch, because to pay out 200 stakers, you can't, right? You can't do that atomically, because you only have 16 transactions in an atomic transaction group at most, and you can only reference 4 accounts per transaction because of foreign references. So even though you can have 256 intertransactions total plus the 16, you're limited to how many accounts you can touch. So it's just not even possible unless you spread it across multiple things. And if it was not atomic, then it gets problematic. So that's why it compounds, which you want it to anyway, to be honest. But it's the same thing with tokens. So the tokens compound, but because the tokens are held in this pool, it has to keep track of how many are spoken for. So like when you say, I'm gonna do 10,000 tokens per epoch, it needs to verify that, okay, I've 10,000 tokens are spoken for, and the reward token held back continues to get incremented. So if you refund yourself, it will never refund, it'll refund everything that's not held back, because those tokens, people, when they unstake, they have to be able to get those tokens. So it just has to kind of keep a little accumulator of what's spoken for in the tokens. How long does the session go to? 12? 12, 15? Okay.
Can stakers join mid-epoch?
What's that?
Can stakers join mid-epoch?
Yes. So one thing that's interesting is, as a part of the actual, if you look at the pool, hey, the only thing that creates the pool to a certain extent is the validator. The pool is told, hey, I created you, and then now it's like this they're conjoined in a sense. So the pool will say, hey, you created me, your state, I expect my state to be found in you, and there's cases where the pools talk to the validator for their data. So like when you call the pool, so like when you add stake, you call the validator contract to add the stake, and then it finds the pool to add the stake to, and then calls the pool and say, hey, add stake. And then the pool says, hey, the only person who can call me is who created me, which is the factory, right? And so there's the combination of things back and forth where the pools validate that the only thing calling them in many cases is either a staker or the validator contract itself. And then there's cases where the pools call the validator and say, hey, who's my owner? Who's my manager? Because if you want to be able to change the manager address, which you can, well, that change has to apply to all pools, right? So you can't call each pool and say, hey, change your manager address. Instead, I change the state in the validator, and as part of a call to the pool, it calls the validator and says, hey, who's my owner and who's my manager, and then checks to see, is that who's calling me? So that way you have a dynamic config. But there's also cases, because there's no reentrancy in Algorand, which is really good actually, but can cause problems. So in the case of, if you look here, there's this pool token payout ratio. Well, because for each epoch, I need to figure out, like if I have 2 pools and I'm giving out 10,000 tokens, that's 10,000 tokens total. So I have to figure out what the ratios are of the pools of total stake and say, okay, this pool has this percentage, this pool has this percentage, and you have to kind of like calculate that once and lock that, because the other pools, when they do their epoch update, might be a round or 2 behind or whatever. So when the epoch update is called for each pool, because the node daemon calls each pool and says, do an epoch update. And then it updates the balances for all the stakers for rewards and all of that. And also based on the entry time. We can get back to that. But as a part of that, if it's pool 1, it goes, oh, have I been called yet for this epoch? Is it, and also is it, am I, you can't call multiple times per epoch. It has to ensure that I've only called once per epoch. So it says, okay, am I being called once per epoch? Am I pool 1? Is there a reward token? And if so, I need to calculate the ratio. And then that pool is able to call a validator, but not back. So pool 1 says, I need to calculate the ratio. If pool 2 gets called, it says, oh, I need the ratio. So it then asks the validator to call pool 1 on its behalf to have pool 1 set the ratio. And then now it can read the ratio from the validator.
Right.
But because it has to do this kind of, so it can't, to avoid reentrancy, you need to very, very carefully, like what calls what has to be very, very clearly defined.
So if the staker joined mid-epoch, they still get the payout for that?
So the way it works is, as a part of joining in a pool, you have, did I get to this? I was doing this in the plane. As a part of the staking pool, I literally have it, this blanked out. But here, I will just show the actual code. So in the staking pool, I can make that bigger. Is that good? Is that good for everyone? Okay. So as a part of this staked info, and that staked info is a static array with max stakers per pool and a box called stakers. And so max stakers per pool is 200. And staked info static is a struct containing the account, their current balance, which compounds, total rewarded, which is just kind of like a nice thing to have, of like this is how much you've ever been rewarded. That does not get reset. It just accumulates. Then reward token balance, which is just your current reward token balance, and then your entry round. And then anytime you add stake, ever, it takes the current round plus 320. Because an Algorand, your balance for consensus is always 320 rounds back. So if someone adds a million algo, well, that million algo actually isn't really going to be seen for 320 rounds. So I don't count that in Reti either, right? So I need to account for the fact that million that you just added won't really be factored into the incentives. So I automatically kind of deduct, in a sense, by adding 320 rounds to their entry round. And so then your entry round in relation to the epoch determines your percent of epoch, right? So if the epoch is an hour, well, 320 rounds is like 15 minutes or something like that. So if I entered right at the beginning of the epoch, then I'm automatically about 25% into the pool because of that 320 rounds. So I would be 75% eligible for that epoch. So what happens is a part of the payouts, it figures out who are the partial stakers. And then it pays them. So if I was 50% in the pool and I was only in 75% of the epoch, I would get 75% of my 50%. So it figures out the partials first, figures out, like, reduces the total reward based on those partials, and then takes that remaining amount and gives it out to all the full stakers. So the full stakers get the excess, right? And then on the next epoch, you'll be 100%. But the key is you have to do that entry time gating, because say my epoch is an hour, and 2 blocks before the epoch, say you've got 1 million algo in there. 2 blocks before the epoch, someone puts 5 million algo, right? And like, you wouldn't want the protocol to be like, oh, you're 5 million out of 6 million, you get, the majority of this reward that's been accumulated, right? Well, you never contributed to that reward, right? So by coming in so late, you basically get 0 that epoch. Now for the whole next epoch, well, now you're there, assuming the 320 rounds, right? That's included too. But that keeps people from gaming. So when you unstake, it doesn't matter. But anytime you add stake, so even if you've got 1 million in there and you add 1, doesn't matter. It can't separate out like each stake and what's percentage. So it's like if you add stake, the entry round is the entry round of any addition. And so then, like, some people might have an epoch of a week, right? So that might make a bigger difference for you to add stake. But I'm assuming most people, because it's quite cost effective all around, most people will probably have shorter, like maybe a day or something. Wow, yeah, like I said, there's a lot to cover here. But I think we're already almost done. So all the contracts is completely open source. Go to GitHub Transaction Lab /Reti, and it's all open source, all in TL script, which is fantastic. Thank you, Joe. And it's the no daemon is in Go, and it's if you go to the releases, it's built for every platform. So you'll see attachments in every release. I build AMD and ARM64 for Linux, Windows, and OS X.
What's the prereq? Like, do you just need a algo D running?
Yep. You need an admin key. That's it.
Okay.
So if you can talk to your node, like you could talk to a public node, and it worked just fine. You just need the admin key.
Yeah.
So if it's on the same box, so here I can.
How would redundancy work? Could I have 2?
Well, you can't really, like, you can't, it's actually like when if you had the same key on multiple nodes, that's bad.
No, sorry, I meant with your stuff. Like, I'm assuming algo D is not going to fail, but if I don't.
I mean, it's a service, so it would automatically restart. I mean, so you would run it as a daemon. You'd run it as a system D service, so it's a single binary. You set up a system D service. I run a lot of my stuff in Kubernetes, so I run it as a pod alongside. So I run it as a container in the same pod as my node. So it's literally localhost. So I just say the URL for algo D is just like localhost : whatever, and it's in the same container. It's the same 2 containers in the same pod, and then I just need the admin key. So if you're running on the same box, then the environment, you just set Algorand data environment variable. So if Algorand data environment variable is set, then it just reads the config from the directory directly. So it'll read the admin token and the URL from the Algorand data directory. So if it's in the same box, you just set the Algorand data environment variable. You set the manager account mnemonic, the validator ID, and the node number, and then that's it. And then it will automatically do everything.
I've made a chart to like help you know what needs to be set up and like record how you configure all the environment variables and like system D service files and things like that. I'm gonna PR it to the
But the node daemon also exposes a Prometheus compatible metrics. So you can scrape that to anything. So like I've got my the the testnet Reti pool. So you see available rewards. Eartho from Nodely is like was kindly doing kind of dummy rewards on testnet to Reti pools. So just so he's basically it's like is it everything online or just specifically Reti pools?
Only Reti.
Okay. So for Reti pools, he detects this is a Reti pool, and he sends like fake rewards to all the pools. So you see, with I have my daemon to be hourly epochs. So these are the rewards that accumulate, and then boom, it goes down to 0. So and then you see the total stake of the pool continues to grow. And then so as the number of stakers, as people come in and out, then this will obviously change. So if I go out, right, then you see changes in stakers, total stake, as people come in and out, and then the rewards. So it's pretty feature complete. The node daemon and the contracts all open source, and I think with and then the full UI as well. So that'll be hosted somewhere. I think was Nodely gonna? I think you said yeah. So there's a good chance that the mainnet will be hosted by Nodely. The UI. And then the UI you can run locally. So there's no back end. It's literally just talking to Algorand nodes, that's it. So I can run, here's the one locally. I can go to the UI. And run dev testnet. Connect, and then I have the exact same UI, all localhost.
I have one ask.
Yes.
Host your validator nodes in North America. Like there's too much stake already there.
Oh, don't do it in North America.
Don't. Host
So like
everywhere.
Hetzner and Amsterdam.
Europe is like in the middle, okay? APAC is missing stake. Please validate there.
So 100% get that information out there. I can help to get the information out there as well. But like, I think it's a matter of like, obviously we want people running it in lots of different places. Ideally, people on their own machines. So it's like you don't necessarily in clouds or wherever. Like if we get a huge diversity of pools and node runners and clouds and people running in their closet, whatever, I think it'll be amazing. Because the Algorand node is, I don't think there's nothing that touches it. I mean, I've run a number of nodes, and in terms of the efficiency, efficiency of the CPU, memory, disk, the amount of I/O per transaction, amount of network traffic per transaction, all that is amazing. And so, as long as box state doesn't get too crazy, the requirements for non-archival nodes is very minimal. So, I mean, I hope between all the different solutions that are going to be out there for pooling, I really hope we see a lot of nodes. But yeah, we're out of time. I could talk about this literally all day because there's a lot to talk about. And I'm sorry I didn't get into any of the code if people wanted to see that. So there's just a lot to talk about in terms of just some of the protocol issues. But there's a Reti channel on the NFT Discord. And then, so there's any questions or issues, like hit me up. Questions? I think it's past time, maybe. Good. Thanks, guys.